Hey, I'm Tyler. I'm an engineer here at Statsig, and I'll be talking through an introduction to the Statsig platform and all that you can do in it. So before we get too deep into what all you can do in Statsig, I think it's maybe a little bit useful to talk about where Statsig came from and why it's important. So originally Statsig was a group of engineers who were at Facebook and were like, hey, the internal tools here are really good and they inform so much of the culture of Facebook. They really enable people to move fast and move confidently in a way that's really cool and you don't always see out in the wild. So hence the journey of Statsig, trying to bring some of those cool superpowers to the rest of the world. So at its most basic level, what you can do in Statsig is control who gets access to a feature. I think this is a pretty natural thing for most engineers or anyone really to want to be able to do with their product. You'll have a feature and you want only a certain country to have access to it. Or you might even just want to have that kill switch in case you need to roll it back because you're seeing lots of bugs. So I think that's the most natural form or the most sort of easy to see reason you might want to use Statsig. But the really cool thing that you can then do is actually understand how that feature is impacting your metrics. I think the sort of traditional way of doing this is you roll out your feature and then you look at all your dashes and you're like, oh, did they go up or did they go down? Does it line up with when I rolled out this feature? But that's not very scientific, and it doesn't actually prove causation. You're sort of just looking at pure correlation. So the really cool thing that we do with feature gates and also sort of extends to the rest of the product is when you have some group of users that are all roughly the same, so maybe you've restricted this to US users or everyone. In that case, everyone is a pretty homogeneous group. When you have a partial rollout, so I'm saying hey, I want 50% of my users in the US to get this feature and 50% of people to not get this feature, the cool thing there is that you actually have an A/B test. You have roughly the same group of users on both sides, so we can fairly compare the metrics between those two groups and say, hey, this feature is what's different between them, and this is what metric differences that resulted in. So what that means you can do is you can actually say, hey, I released 5 features and my revenue went up. You can go back and actually sort of attribute out what features caused what, or as the case may be, figure out what features caused what regressions. There's a pretty famous study in experimentation that Rani Kahavi did back when he was at Bing, where he went and looked at all of the features that they had released and what they sort of had hypothesized that this change would do. And so they found that every feature you think is going to be good, right? Why did you spend all the time going and building this thing if you don't think it's going to improve something, right? You have some sort of innate hypothesis that something is going to be improved by your feature. And what they found is that about a third of the time, that was right. They improved whatever metric they were trying to move. I think for Bing in particular, they had one core metric that they were always trying to move. But in general, a third of the time, you improve the thing you're trying to improve. About a third of the time, it was sort of, let's go back to the drawing board. Maybe we need to iterate on this a little bit. It just didn't do what we wanted it to do, but didn't really do anything bad. It was kind of just neutral, right? And then what they found is that about a third of the time, it actually hurt the metric they were trying to move. The really cool thing here is that if you are actually running all of these as experiments, you can find when those degradations happened and actually remove them, right? That's really powerful. I think a pretty common chart that people like to use in the industry is sort of this your development is sort of like a step process or a wave function where you go up and then down and then up and then down and then up and then down. What you're doing here is you're really just removing those little dips, right? There's no need to take on all of those dips to your product's metrics if you actually know that they caused a dip. There's kind of a famous line that's at least attributed to, if not actually said by Nelson Mandela, where he says, I never lose, I always win or learn. And I think that's really relevant here as well. You just develop so much better of an understanding of A, what features work, and B, of your actual user base. I think there's the classic head-to-head between, hey, like I'm going to experiment on everything, or I'm going to go on pure product sense. And in my opinion, at least, the way that you develop your product sense is by experimenting on everything. They're very hand in hand. It helps you design good experiments if you have good product sense, and running experiments helps you develop good product sense. So talking through Statsig itself now that we've sort of gone through why you should care about experimentation, why it's cool, why it's powerful, we'll go through the most basic thing that you can do in Statsig, which is set up a feature gate. A feature gate always just returns true or false. Either this user has or doesn't have this feature. What you can do is you can set up individual rules on the gate. So you can say, hey, I'm going to restrict this to employees only. You'll say, this is how I know if someone's an employee. And then for those users that are contained in that rule, if they should get the feature or not. So you'll see a lot of interesting conditions that you can set up. You can say like, hey, this other gate needs to be passed in order to get this. Maybe, in order to be a producer of this type of content on your platform, you need to be able to consume that type of content on your platform, things like that. Or maybe I have like an early access rollout to a certain country or to certain devices. There's lots of conditions that you can use to control who gets what access. And then the cool thing you can do is sometimes on a rule, instead of saying everyone who passes this or no one who passes this should get my feature, you might say, 10% of people who pass this, or 50%, or 90% of people who pass this should get this feature. And then whenever that happens, we'll always turn that into an A/B test and let you actually say, hey, did this feature for this group of users improve or deprove various metrics? Experiments are sort of like feature gates cousin, but a little more experimental rigor applied to it. The thing I like to think of here is going back to like high school or middle school science class. You learned how to design a good experiment, right? You were like, here's the hypothesis, and then here's the test I run, and then I look at the results of that test and see if they confirm or disprove the hypothesis, and then I will go and iterate on that, or I'll make conclusions off of that, and sort of just keep repeating that cycle over and over. You should actually really take that like scientific method approach with you when you come to experiments. And we actually have a spot where we're like, hey, tell us what your hypothesis is, right? Instead of saying, I'm just going to give users this feature or not, I'm going to say, hey, I want to give users this feature because I think it's going to do X, Y, or Z to my metrics. The other thing that's a little bit different between a experiment and a gate is that for an experiment, you actually can support A, B, C, D, ABN type experiments. Instead of saying only you have the feature or you don't, you can say like this group of users gets this variant and this group of features get this variant and so on and so forth. The other thing that is pretty cool about experiments is that you can actually have mutual exclusion between them via our concept called layers. So what this means is that you might be having a checkout page and you want to say, hey, I'm running an experiment on the checkout button, but I'm also running an experiment on how we display your address. And I just think it's too confusing for a user if both of those might change. So I want to separate them out into two separate experiments where you can only have one of them affecting you at a time. That's a layer. The other sort of interesting thing about how we like to think about experiments is we have this concept called parameters. Most products out there tend to really zero in on group name as how you determine which variant you're in. You're either in ARM1, ARM2, ARM3. We think you can write a lot cleaner code and sort of more extensible code if you use these things called parameters, where you're actually saying, instead of it being that I'm either in checkout button 1 or checkout button 2, I'm actually going to say, for checkout button 1, this is the color you should make the button, this is the text you should put on the button, this is how big the button should be, and ditto for checkout variant 2. So that will allow you to actually iterate on that experiment a lot faster because you're already checking these things, and also it means so much less branching in your code in a way that makes it a lot easier to keep clean. And so once you've run an experiment or you're looking at the results of a Gates A/B test, you can get what we call pulse results. This is our version of displaying exactly what has happened to the users in your test. we take all of the users in group A and all of the users in group B, and we look at all of their metrics, and we say, okay, the average for this metric for this group was X, and the average for this metric for this group was Y. Let's look at that comparison and actually like add some confidence intervals to it and do all sorts of cool statistics stuff there. For a experiment, we like you to divide things into what we call primary and secondary metrics. The primary metrics should be the thing you're trying to move with the experiment. This is sort of directly your hypothesis. Some organizations take the approach of everyone is always trying to move the same hypercritical business metric. There's like always one, and maybe it's revenue, maybe it's conversions, something like that. Other organizations, this will sort of vary a bit more per experiment, where it's like, oh, I made a change to the checkout flow, so I'm trying to move checkout conversion, things like that. The secondary metrics is where a lot of people will call guardrails as sort of a way to refer to this, or maybe you just put all of your core business metrics here. Secondary metrics are things that, in my mind, are what stop you from shipping an experiment. So this is, hey, this is why, even though it was really good for the thing we were trying to move, it hurt performance, things like that, where someone could pretty reasonably come to you and say, no, sorry, we can't ship this because it hurt this thing. So in my mind, primary metrics are why you ship something, and secondary metrics are why you don't. We also have what we call the Explorer tab that lets you do a lot more slicing and dicing. So the Explorer tab is your home for, I want to look at how only users on Android were impacted by this, or I want to look at how users in Mexico were impacted by this, or maybe there's just a bunch of other metrics that aren't in your primary or secondary metrics that you also just want to look at. The other cool thing you can do in Explorer is you can do like very specific time windows. So maybe it's like, I want to see how it did over the past week, but Thursday of last week was Thanksgiving, so I think my metrics are totally different for Thanksgiving and Friday and Saturday. So I could exclude those dates or only look at those dates. Really just try to do all the slicing or dicing that is useful. The other cool thing you can do in Pulse is lots of different time series type views. One really common one that people like to look at is what we call days since first exposure. So what that is it's actually breaking down your users into cohorts of this user was exposed on this day, and then what were their metric results on that day, 2 days later, 3 days later, 4 days later, 5 days later, 6 days later. The really cool thing you can find there is novelty effects. So, if I change the color of a button, a lot of people will sort of just click it because it's different than it used to be. Maybe it catches your eye a little bit more, but I didn't actually give them net new value that's going to make them long-term press this button more. It's just new and shiny, so people click it. So what you'll see in a situation like that is your metrics will start out really high, and then they'll sort of just go back to mean over time. That's a pretty cool thing that you can often find in the time series views on Pulse. So let's talk about how you can actually get these metrics into Statsig. There's 3 main routes for getting them into the cloud version of Statsig. It's a little different if you're using the warehouse native version of Statsig. But so in Statsig Cloud, you can log an event directly to us using the SDK. So this will sort of look something like log event foo value 3, and I can put whatever other metadata I want in there. This is representing a sort of atomic unit of a thing happened on your platform. The things you can think of, here are a person went to a certain page of your website, or a person purchased an item, or I clicked on an item, or I sent a message. Things like that are things that happened on your website. They're not metrics themselves, but metrics are built off of those. The other thing you can do is you might already be collecting these metrics via other sources, so maybe like a segment or mParticle or what have you. So you might already have these events flowing somewhere that you can look at them, amplitude, segment, etc. And you can just say, hey, amplitude or segment, just also send those to Statsig. I want to see them there too. I want to be able to build things off of them. They function just like if you had logged it directly to us. It's just, did you use our SDK to send it to us or not? And the same exact way, they'll function as a building block for your metrics. So once you have some events, you can go and say, a thing that I might actually care about for a user day is how much did they purchase? How many times did they purchase? How many dollars did they spend? Those are metrics. I purchased this item is an event, but it builds a metric. You can also just import metrics directly to us. These are probably things you already have, most likely, where you compute some value somewhere in your warehouse or what have you, where you are like, this user for this day had this value. Everything we do is based on user day values. Yeah. So you can send those directly to us, and we'll just take all of them per user, do all the math on this user was in this experiment, and this experiment, and this experiment, and compare the averages for you. So like I said, an event is a actual like atomic building block of a thing happening, and a metric is this is a actual value I care about tracking. It can be simple sums, it can be ratios, it can be averages. We let you build a decent number of these in Statsig itself off of your events. So we let you do things like, I want the average of events that look like this, where I'm adding these filters, or I want the ratio of how many times this event happened to this event, things like that. And of course, you can go as creative as your heart desires if you are doing everything on your own end and just importing them directly to us, as long as you're able to compute something for this user for this day had this value. So I want to quick talk about the different ways people use Statsig. There's two main paradigms, really, and a lot of people use both. You can either have us running on your servers or on your clients. There's some slight differences, but in general, we think we've made the trade-offs that are most appropriate. A server SDK will actually sort of grab all of those rules that you configured in Gates and have them in your server so that when you say, hey, I have user Bob who has email bob@gmail.com, what should they get back for this gate? It happens totally locally. They don't have to send a network request to us and back. You just evaluate it then and there. The server SDK is really cool because it lets you handle a lot of different users at the same time, because everything is happening locally and you have all the rule sets there. As a user comes, you can just evaluate it and return the response. And then we'll also sort of just poll over time and make sure things are up to date. With the client SDKs, we tend to think a lot more in the terms of like a session for a user. If I'm using an app on my phone, it's not really me and all my friends using the app on my phone and I'm passing it around. It's me using the app on my phone. And so in that world, I will, at the start of my session, I will grab all the values for all the gates so that I'm still not having to make a network call every single time I want to check something. I just look it up locally in the dictionary. So it's really hyper fast. And yeah, it works really well for a single user. The other thing that's worth noting as we talk about users is how do I like what goes into a user object. At its core, it's sort of a list of properties. So that might be something like, I'm from this country, or I'm on an Android device, or things of that nature. And then what we call IDs. So an ID is just a way, an identifier for a user. So the most common that we have right out of the box are what we call user ID, which is basically your default mechanism for recognizing your users. This should be whatever you use in your system to refer to a user who is sort of signed into things. And then we have what we call a stable ID. This is auto-generated by us if you're using a client SDK, and it's a way of saying this device, and we just throw it in local storage and just always are able to refer to this device. So the stable ID you get out of the box on all of the client SDKs, and then user ID is a really straightforward one to throw a value into. You can also add custom IDs. The way I like to think about all the different IDs is it's multiple things that are describing one quote-unquote user. So if I am logged into some like enterprise site, right, where, hey, I'm an employee of Statsig and I'm Tyler, a employee of Statsig, I would have some like company ID that's like, here's Statsig, and then some user ID that's here's Tyler. I'm both of those, right? If I were running some experiment that's changing behavior at the company level, that's totally fine and kosher, and I'll just get back whatever my company is getting, right? Whatever all my peers at Statsig are getting. And I could also run some experiment at the user level, and then my experience might be a little different than one of my colleagues here, but like my experience is still consistent for me. And so the most important thing in experimentation is that your unit of randomization, as we call it, should match your unit of analysis. Your unit of randomization is how you're doing that split. So if I said 50% of people get this feature, does that mean 50% of companies or 50% of users get this feature? And then when I actually go and look at the metrics, I should compare along that same unit. If I put half the companies in this bucket and half the companies in this bucket, then I should look at metrics per company. If I put half the users in this bucket and half the users in this bucket, I should look at metrics per user. And we'll do that for you. Just worth noting that you should think a little bit about what you want to randomize off of. Cool. So that takes us through most of the high-level topics about all things Statsig. So we really appreciate you listening to this session. Thanks.